Okay, here's one more example of integration by substitution, and this time we'll do a problem involving some trig functions. And we'll do it with the substitution and again with the substitution with change of limits. So again, we'll work this one two different ways. Okay, take a look at what we're integrating here. Sine to the fifth 2x times cosine 2x. Notice we have a sine, it's raised to a power, but it's a sine function, and we have a cosine function. So think of it as the sine function here and the derivative of the sine function. When you have one thing and its derivative showing up, that's a good clue that the thing can be our u, and then that the derivative of it will end up being the du. So watch and we'll see that happen. Okay, so here's the substitution. I'm going to let u equal the sine of 2x. And there you can see what we have right here is u to the fifth. So if u is sine 2x, then du dx is just the derivative of that. That'll be cosine 2x times 2 by the chain rule. So du dx is 2 cosine 2x. So du is 2 cosine 2x dx. Now notice what we have up here. We have, remember, u to the fifth right there. And then this cosine 2x dx, look at that. Just a factor of 2 right there. So cosine 2x dx is half of my du. So remember, I have a u to the fifth and a half of my du. So let's rewrite the integral that way. This is the integral. Now notice I'm going to put a x equals 0 to x equals pi over 8 to remind me of those variables. But then I have a u to the fifth times 1/2 du. Now at this point we see the inconsistency. We have x's here and u's here. And we need to either integrate and then substitute this stuff back into terms of x, or we need to substitute here and change the limits to make those in terms of u. And I'll work it each way. First I'm going to go ahead and integrate and then substitute back in terms of x. So this is pretty easy to integrate. Let's just bring the 1/2 out front, and then we integrate u to the fifth, and that gives us u to the sixth over 6, and this is evaluated from x equals 0 to x equals pi over 8. And to allow us to substitute these values in, which are x's, I need to substitute in that u, my expression for u in terms of x. And u was sine 2x. So my problem becomes 1/2 times sine of 2x to the sixth over 6, and I'm integrating from x equals 0 to x equals pi over 8. And I can substitute those values in. This will be 1/2. Now let's put in the pi over 8 first. Okay, when I put in pi over 8 for x right here, 2 times pi over 8 is pi over 4. So this is the sine of pi over 4 to the sixth over 6 minus, and then when I put in a 0 right here, I have 2 times 0 is 0, and the sine of 0 is 0, and 0 to the sixth is 0, so it's just minus a 0. And this equals a 1/12, I'm just combining the denominators there, times the sine of pi over 4 to the sixth. And the sine of pi over 4 is the square root of 2 over 2. That's to the power of 6. So this ends up equaling 1/12 times the square root of 2 to the sixth is the same as 2 cubed, which is 8, over 2 to the sixth, which is 64. So 1/12 times 8/64 comes out to 1/96. That's my answer. 1 over 96. Okay, now I'll do the same integration with the change of limits, and we'll see, of course, that we get the same answer, 1 over 96. Okay, here's the problem. Again, the same problem, the integral from 0 to pi over 8 of sine to the fifth 2x times cosine 2x dx. And the substitution is u is equal to sine 2x. So again, it starts off the same way. Du dx is 2 cosine 2x. So du is 2 cosine 2x dx. So I can rewrite the original integral as the integral from x equals 0 to x equals pi over 8 of u to the fifth times 1/2 du, because if u is sine 2x, then this sine to the fifth 2x is my u to the fifth, and then this cosine 2x dx is half of my du. And now I look and I see that I have a u and a du here, which is good, but the limits are x values. So what I'll do now is change the limits to u values, and here's how I do that. U is equal to sine 2x. That's just the substitution I had before. U is equal to sine 2x. So when x equals 0, u is equal to the sine of 2 times 0, which is just 0. And when x equals pi over 8, right there, u is equal to the sine of 2 times that. So that's the sine of pi over 4. And the sine of pi over 4 is the square root of 2 over 2. So those are the values for u that I'll plug in here instead of x values. So the original integral then can become the integral from u equals 0 to u equals the square root of 2 over 2 of 1/2 u to the fifth du. And that's pretty easy to integrate. The 1/2 comes out front, and then I have u to the 6 over 6, and that's evaluated from u equals 0 to u equals the square root of 2 over 2. And I have consistency here. These are u values, and they can be plugged in for the variable u right there. So let's do that. I'm going to combine these denominators here. This gives me a 1/12, and then u to the 6th, this is going to be the square root of 2 over 2 to the power of 6 minus 0 to the 6th over 6, which is just 0, like that. And this gives me a 1/12 times 8/64 as before, and it comes out to 1 over 96 is the answer, same as before. So again, we did the integration with the substitution, and again with the substitution involving a change of limits. And of course we get the same answer both times.